Welcome everyone to the.electrica YouTube channel. Today we are going to start a new series of videos that is intended to cover the important interview questions genuinely asked in technical interviews for electrical engineering domain. So the series will be interview question series and we will call it the resistance. First of all, there is a note for the audience. This video is an advanced level guide for the viewers, not intended to the beginners in this topic. And the key intention of the resistance series is to enable engineering graduates or diploma engineers to clear their depth concepts regarding the topics and so that they can perform well in the job interviews. Prerequisite for the today's topic, that is Ohm's law, will be basic understanding of Ohm's law, resistance, current, potential difference, voltage source, current source, and the concept of circuits, open circuit, closed circuit, and basic science and mathematics of 10th level. So let's start today's topic, that is Ohm's law. First of all, it may be surprising for you that why so simple topic, Ohm's law? Why not something like transformer, DC motor, all those things? Because generally it is a very preliminary level thing in electrical engineering. But why I want to start from the Ohm's law is recently one of my students faced a job interview and generally, in my lectures or classes in offline mode, I uh, teach them all the things that regarding transformers, okay, and regarding motors and everything like that, machine, transmission line, distribution line, cables, etc. All those topics, those are very advanced topics. But to my surprise, he was asked to say Ohm's law. And this same thing was covered by me in their offline classes as well at the very beginning stage. And he was a very potential candidate for the interview. But surprisingly, he could not answer it properly, that what is Ohm's law. And he didn't got selected. So that is why I thought that initially I will start from the very basic topics. Okay. So that's why Ohm's law. Now, one question arises that why we need Ohm's law. See, when we are learning something, we should be knowing that why we are learning something, right? So it is first question from me to you guys is that what is Ohm's law and why we need it? Okay. So first, what is Ohm's law? See, the basics is if temperature and other physical parameters remain constant, current I flowing through a closed circuit will be directly proportional to the voltage applied across it. And there is a condition that if there is no nonlinear element in the circuit. So what does it say? It is simply like that. Say this is a given circuit, okay, and this is a resistance. I have a switch here, okay, and I have a voltage source plus minus and disconnected. This is resistance. Now say the voltage is V, EMF, and when I close the switch, what will happen? Due to this EMF or battery, there will be a voltage across this resistance and a current I will flow through the closed circuit. Okay, so the current will leave the positive terminal of the battery and circulate like this. Okay, now this is something like practical. Okay, But physically, see what we have written is that why I am emphasizing on this point. See, I have written a closed circuit. Okay, generally in the books it will not be written a closed circuit. Okay, and I will explain it later that why this closed circuit is important. Now I am highlighting these points. Okay, and I have also mentioned this point that if temperature and other physical parameters remain constant, so I will also come to that why this temperature and other physical parameters need to be remain constant. Okay, and another important thing is that there must not be any nonlinear element. What is nonlinear element? Nonlinear element means in the said elements, the current flowing through the element will not be proportional to the voltage. For example, if current is proportional to the voltage, the graph will be like that. Okay, see, this is voltage and this is current. So the graph will be like that. This is for linear elements. But for non-linear elements, the graph will be something different. For example, we are increasing the voltage and the relationship is not linear. Okay, this is called non-linear. This is non-linear. Okay, we are increasing the voltage here for the amount of unit increase in voltage. The current is increase in current is this amount. But here for the uh, unit increase in voltage, the amount of increase in current is more, right? So this is nonlinear characteristics. But for linear characteristics, if you increase a unit voltage, the increase in current will be same. Here also, if you increase unit voltage, the increase in current will be same. Okay, this space, okay, increase in current. And so, for example, nonlinear elements are diode, okay, and semiconductors. Okay, so these are nonlinear elements. Okay, now, so what is Ohm's law? You all know. Okay, there is nothing very hard and fast. Okay, so my question is, why Ohm's law? Why do we need Ohm's law? See, if we know a voltage or potential difference or EMF across an element, a current will tend to flow through it. This is general physics. For example, the if the element is a pencil and we are connecting a voltage source here, okay, say battery. So a current will flow through this element that is pencil. Okay, there will be a current I. If the element is a wood piece, okay, a wooden piece, here also some current will flow or tend to flow. Okay, it might not be any measurable current, but at least current will tend to flow. It will try to flow, but if the resistance is high enough, there will be no current. Okay, and similarly, if there is a bucket of water and we are connecting a voltage source, the current will try to flow through this positive terminal, then through the water, and then it will come back to the negative terminal. So, okay. So that is general physics. If we apply a voltage or potential difference or EMF across any element, a current will tend to flow or it will flow. Okay. Now, for measuring this current, we can simply use an ammeter or multimeter. Okay, we just need to connect in series with the circuit or with the particular element. For example, I have drawn a picture here. See, I want to measure the current through this resistor R, and I have connected the multimeter's probe with this. Okay, see, I have connected the positive probe of multimeter here or negative throw of multimeter here, and I can show the ampere reading. Or else I can directly connect, instead of multimeter, I can directly connect a ammeter A, and I can see the deflection of the pointer, and I will know the current. Okay, so then why I need Ohm's law? I have multimeter, I have ammeter. Then what is the importance of Ohm's law for me being an engineer? Okay, there is no practical need. Is that right? No, it isn't. Why? Because in practicality, we are not going to calculate the currents using any mathematical formula or simulation tool. I know there will be an ammeter either connected in series directly to the circuit, or in case of high current or high voltage circuits, power circuits, there will be a CT. Okay, and with that CT, the ammeter will be connected. CT means current transformer. Okay, CT is current transformer. Okay. Now, uh, for being an engineer, you need to measure the current for testing, troubleshooting, or commissioning. We may use a multimeter and connect its probes in series, right? And that will be fine. But if you think deeply, uh, for example, in a circuit, the current is 10 kiloampere, and we are using a simple small multimeter whose range is might be up to 100 amperes. Okay, it is also very big range, up to 50 amperes. Okay, and we are connecting this multimeter to a 10 kiloampere circuit. Simply, what will happen? The multimeter will be blown up, or else you can imagine like that. You need to fix a ammeter in the panel, okay, to measure the current. And we are fixing a 10 ampere ammeter to measure 100 ampere current. The actual current in the circuit is 100 ampere. So the ammeter will overshoot, okay, or it will just got burned. Okay, it cannot withstand that amount of heat produced by the 100 ampere, because it is designed to measure only 10 amperes of current, right? So how would we know that what should be the size of conductor used in the circuit? Okay, for example, we need to design a circuit where the expected current is 100 ampere, and we are applying the conductor which only can carry 50 amperes. Okay, how can we know the uh, size of conductor? Okay, we cannot measure before we connect the conductor, na? Okay, and similarly, the current rating of the various elements of the circuit, that for example, we are going to put some electronic circuits, or put some uh, heater, put some iron. Okay, how can we know that what should be the current rating of this iron? Okay, we cannot know. And same in high voltage transmission lines, that what should be the conductor size. Okay, that we need to determine. Now we cannot measure until it is the transmission line is installed, right? So then how can we calculate the current, that what is the expected current through this transmission line, and according to that we are going to select the conductor size. So it is not possible to physically measure the current by ammeter or multimeter. Okay, it may be in a practical way, in a existing circuit we can measure it. Okay, and that too requires the knowledge of the range, that in this circuit the range of current will be 50 ampere. So we are taking a ammeter of range 60 amperes and we can measure it. Okay, but if we don't know the range, we cannot apply any multimeter or ammeter there, because we don't know that how much current is expected. Okay, that is why we should be able to calculate the amount of current flowing through a circuit or any element of the circuit, or voltage drop across a element while designing it, right? Because physical measurement is only possible when it is existing, when it is installed. But before installing, we need to know various things, right? Here comes the importance of Ohm's law, that it is like a tool which establish a mathematical relationship between the current flowing through a linear element and applied voltage across it, or voltage drop. And if we know the current and voltage, we can anticipate the resistance, that this is the resistance in the circuit, and it is applicable for DC voltage as well as AC voltage. And majorly used in transmission lines, in any electrical circuit, from small scale electronic circuit to transmission lines, appliances, domestic circuits. Everywhere, while you are designing it, you can anticipate the values from any given two quantities. That if we know any two parameters like voltage or current, we can find the resistance. If we know voltage and resistance, we can find the current. If we know current and resistance, we can find the voltage or voltage drop across the element. So that is why a mathematical expression relating all these three parameters is very important, and that is the application of Ohm's law. So in an interview, what will say that why Ohm's law, or what is the application of Ohm's law? I hope you all can answer it. Now, in books, the definition of Ohm's law is written in some way that, if I explain, that say there is a conductor like this, okay, and the 2 points of the conductor is point A and point B. Now, in physics, they say that, say the potential of this point A here, this point A is here, okay, is VA, and the potential of this point B here is VB. Now, if there is a potential difference, okay, if VA and VB is different, so there will be a potential difference. The potential difference will be VB minus VA. Then what will happen? A current will flow through it. And the current will be, say, I. And the resistance of this element is R. So now what Ohm's law say is that the current flowing through the element will be proportional to the potential difference. And further, if we calculate mathematically, it will be like that: I equals to VB minus VA divided by R. Now, being a student of engineering, you should think that for us, merely an element is nothing but a open circuit. For example, there is a circuit like this, okay, there is a switch, there is a battery, and this is resistance R, and this switch is open. So will any current flow through the resistance? Will there be any current? Certainly not, because it is an open circuit. Theoretical physics is something different, okay. It is saying that there will be a current flowing through this portion, but we cannot measure it because we cannot connect any ammeter. But in practicality, there will be no current, there will be no useful current through this resistance, right? So if we only make the switch close, then only due to this voltage V, a current will flow through the resistor, okay. So that is why I will highlight it as a closed circuit, okay. So what I recommend you to say in the answer of being asked that what is Ohm's law is that if temperature or other physical parameters like length, cross-sectional area, etc. remains constant, the current flowing through a linear bilateral element in a closed circuit is directly proportional to the potential difference or voltage applied across it. Okay, maybe you may add a applied or voltage across it. Okay, so that is more significant. Okay, that is in more engineering way, because unless it is a closed circuit, current cannot flow, right? Now, another thing is temperature. Why temperature shall remain constant? It is because of alpha. What is alpha? We all know that alpha is the temperature coefficient of resistance. See, if the resistance is constant, then only you can tell that current will be proportional to voltage. If the resistance is changing, okay, for example, if we say mathematically, the current is proportional to the potential difference, right? So if we write it, it will be like that: current is proportional to the potential difference V. Now, there will be a constant of proportionality. Here, in case we take 1 by R as the constant of proportionality. So, what is 1 by R? It is the conductance. And what is R? It is the resistance. This R. Okay. And if we further derive mathematically, it will happen I equals to V by R, right? And V equals to IR, I into R. Okay. Now see, if this resistance changes, okay, for example, initially what was the case? The voltage was 10 volts, okay, and the resistance was 2 ohms. So what will be the current? The current will be from this formula V by R. So it will be 10 divided by 2, okay, that is 5 amperes. Now if this resistance changes, okay, what will happen? Say the resistance is now 5 ohm. So what will be the current? 10 by 5, that is 2 ampere. So resistance has a directly impact to the current. So in order to this formula be empirical, we need to make this resistance constant. Otherwise, there will be no importance of this formula, because if resistance varies, we cannot predict that current will be proportional to the voltage. For example, we are making in the second scenario, we are making this voltage 20 volts. Okay. So what we'll expect, that as the proportional increase in the voltage have become twice, right? So the current should also become twice, that instead of 5 ampere, the current should be what? Twice 10 ampere. But what we did, we increased this resistance as well. The resistance is now, for example, this resistance is, instead of 2 ohms, the resistance became 10 ohm. Okay. So now what will be the current? The current we are anticipating that this current shall be 10 ampere, but as the resistance has also increased, the current will remain only 2 ampere, right? V by I, so 20 by 10, that is 2 ampere. So we thought that we have increased voltage, so the current should be increased, but as the resistance is not constant, resistance has increased, the current will be 2 amperes. The current will be reduced instead of being increased, right? So the resistance should be constant, and in order to being the resistance to be constant, the temperature coefficient shall be same, okay, in both cases, and so that the temperature shall remain constant, because we know if temperature increases for metals, the resistance also increase, and if temperature decrease, resistance also decrease. So in order to keep the resistance same, the temperature should be constant. And another part is other physical parameters. So this part is really interesting. Why other physical parameters like length, cross-sectional area, etc. to be constant? See, resistance of any element is dependent on the physical parameters of the element. For example, this element length is L, okay, and this cross-sectional area is A, and material, that is, we term it as specific resistance, okay, or resistivity, that is rho. This depends on the material, that it is copper or it is aluminum or it is silver, okay. So the resistance is a composition of these three. So what will be the resistance? R equals to rho L by A. Now, if we vary the length, the resistance will vary. It will increase if we increase the length, and it will decrease if we decrease the length. If we vary the area, for example, we are increasing the area, so resistance will decrease. If we decrease the area, the resistance will increase. And if we vary the material, that is specific resistance, so if we increase it, the resistance will increase. If we decrease it, we select better material instead of copper, we select silver, the resistance will be less for the same given physical parameters. For example, there is a element of length L and cross-sectional area A made of copper. The resistance will be some say X. Okay. And for the same length and cross-sectional area, if the element is made of silver, the resistance will be less than X because silver is a better conductor, right? So that is why we need to mention the term physical parameters. Okay, because it has impact on the resistance. So if these things remain constant, then only the current flowing through the linear bilateral element in a closed circuit is directly proportional to the potential difference or voltage across it. Now another important part is this thing, linear bilateral element. Why linear bilateral element? Because there are some nonlinear elements like semiconductors, diodes, where the Ohm's law doesn't hold. Okay. For example, if I take a slide, for example, the graph of Ohm's law is like this: voltage, current. If we increase the voltage, the current will increase in a linear way. Okay. This is for ohmic conductors. Basically all the metals. Okay. Now, if we take a diode, the graph will be like that. The graph will be like that. We all know that diode characteristics is this. Give me a second. Okay. So the graph will be like this. This is for diode. Why? Because see here in the ohmic conductor, if we increase the voltage by 1 volt, the increase in current will be some proportional. Say increase is 2 ampere. Okay. Now if we increase the voltage by another volt, that is 2, so increase in current will be same. The current will become here, the current will become 4 ampere. But in case of diode, see here there is an increase in 1 volt, but the current has only increase in 0.5 ampere. But in the next case, when we increase the current by another volt, the current is 2 ampere. So this is called nonlinear characteristics. Okay, so diode is not a linear element, it is a nonlinear element. Okay, so in case of nonlinear element or non-ohmic conductors, Ohm's law doesn't hold. Okay, so that is why it is important to mention this linear element. Another thing is bilateral element. Why bilateral element? Because see, there is a diode, another resistance here, and we are connecting it to a battery. Here is a switch. Now if we close the switch, as the positive terminal of battery is connected to the diode, the current will flow. Okay, but if the battery is connected in other way, say this is the positive terminal and this is the negative terminal. Okay, so what will happen? The diode will not allow any current to flow through it. There will be no current, right? So that is why this type of unilateral element, that is which allows conduction in only single direction, these are called unilateral elements. Okay, unilateral elements. This if this type of unilateral element is present in the circuit, Ohm's law will not be hold. Okay, only in case of bilateral element, that is for example resistance, okay, conductors, okay, bulbs, these type of elements will follow Ohm's law. Okay, that is why it is important to mention this part, bilateral element. Okay, so mathematically you can tell that mathematically current will be proportional to the voltage. Okay, this is the symbol of proportionality. Okay, and mathematically we can obtain three formulas. That first is I equals to V by R. Okay, so if we know voltage and current, if we know voltage and resistance, sorry, we can determine the current. Second formula is V equals to I into R. So if we know the current and the resistance, we can determine the voltage. Okay, another formula we can derive, that is R equals to V by I. This is the third one. So if you know the voltage and the current flowing through it by any means, for example, by ammeter or multimeter, we are measuring the current through this resistance. Okay, we are measuring the current through this resistance, and we know we have connected this 5 volts battery and the current is 2 ampere. So we can tell that what should be the resistance. The resistance should be V by I. That is, it should be 5 by 2, that is 2.5 ohms. Okay, so these three formulas are going to be very useful for us, and that is why Ohm's law is very important. So I think you are now accustomed with the concept of Ohm's law, and I think this answer will be a very suitable answer for you in case of any job interview, and it will highlight you among the other participants in the interview, and you may shine, right? So that's all for today's video, and from today onwards we'll be uploading more videos in this series, and for the next day I am giving you a question. Okay, the question is, we all know that in engineering every quantities are determined by some logical way, like if it is voltage, okay, if it is voltage, we'll symbolize it by V, right? So in case of current, it should be symbolized by C, right? Because there is a synonym. And surprisingly, we represent current by I. So my question is, why I instead of C? Now, some of you may answer that, sir, or C is already occupied by capacitor. Okay, so maybe that is why you are using I. Okay, and that's the thing. But my question is again that instead of I, we should have selected X, we should have selected V, sorry, we should have selected Z. So why you're not selecting X or Z, all these things? Why you are selecting I? Okay, so this is a tricky question. Actually, the same was asked by an interviewer to my student, that why we represent current by I. So I am raising it to you for the uh, upcoming video. I will give the solution. Okay, so let's call it a day. Thank you everyone. Happy learning.